All right, the equation is, there's something a little more challenging about this equation. It does follow that kind of PERT formula. It's initial amount times E raised to the 0.166 times T. What's different about this is in every word problem we've done so far, we've known the initial amount. In this one, there's more than one right way to go about it. So some of you might be coming up with a right answer in a different way, and that's okay. So we're gonna have to use something to figure out the initial amount. It says A is the number of bacteria at noon. It then says at 1 p.m. there are 30 bacteria. How many bacteria are at 3:45? Well, we need to find A. So we're going to use the information they give us about 1 p.m. So this sentence can be thought of as a data set for the function. This would be like an ordered pair 1, 30. And T here is X. So we would put 1. This is 1 hour afternoon. So we can say 1 hour after the initial amount, there were 30 bacteria. So we'll put the 30 in the result spot in Y, and that'll help us find A. So Y, no. So 30 equals A times E to the 0.166 times 1. And so even though they didn't tell us A, since they told us this data set 130, we can find A. So we could go ahead and hit the E button in our calculator, Euler's E 2.71, and raise it to this rate. Or we know it's going to be a decimal because E is an irrational decimal to start with. So let's just divide it like it is. Divide both sides by E to the 0.166. To cancel it. And now we can just use the fraction button in our calculator. 30 over E 0.166 will give us A.
So E is the only one that has the exponent attached to it?
That's right.
Okay.
That is right. Yesterday we talked about this PERT formula with compounding interest continuously. This is that same thing. I said there's other applications other than finance. Here's a good one. So principal is what we call the initial balance in a finance scenario, but we can just call it initial amount here, E. We put the rate up high. This is the growth rate for this bacteria, 16% every hour. And then time. So this is just like the finance problem we did yesterday, written with just N of T and A instead of Y and T. So same thing. Anybody get a number yet? Anybody get a number yet in that calculator? How do you decrease by 16%? I'd like to think about that for a while. Go back in time 16%. What is 16% of 30?
Like 4. No. Around there.
Yep. 16% of 30. So 1/3, 0.3. You're gonna 1/6, I think. Well, what's the answer, Marlon? Did you get an answer yet? Can you take those headphones off, please? Did anybody get an answer yet? Did I hear 25? I think it's 25.
Wait, 16% of 30? Wait, what did you say the thing was? Yeah.
What is 16% of 30? Did you do it?
Okay, 4.8.
What's 30 minus 4.8? Ooh, pretty close. I got her go down a rabbit hole.
That would be 26.2.
Okay. So that's pretty close to what we found with our algebra. So anyway, the point was this is growing continuously, 16% continuously, 16% growth over time. So anyway, 30 divided by e to the 0.166 gives us a. So we just found our initial amount, 25.41. So now our new equation with our a value plugged in, Euler z 0.166 times c.
Why did we find 4% of 30? I meant 16% of 30.
Well, this was saying, I was just exploring it because this is the 16% growth. And this was an hour afternoon. So 1 hour afternoon was 30. So I thought if we could reduce about 16%, we could go back in time, 16%, And that worked pretty good. We were pretty close. But this is the more accurate way to do it.
So we already found X, now there's more we have to do?
Yeah, the actual question is find the number of bacteria at 3:45. So if the scenario starts at noon and we're supposed to find 3:45, how much time has gone by? Yes, very good. At 3:45, I used to think 3:45 would be like 3.45. However, 45 minutes is 75% of an hour. So we're going to put 3.75 hours have gone by. So we're going to do t equals 3.75. And then we're going to finish this question off. Anyway, does anybody know how many bacteria it takes to make you feel sick? The tuberculosis bacteria? Does anybody actually know what the disease entails? Is it headache, stomach ache? Guess it's just not that relevant anymore. Yes?
47.35.
Good job. 47.35. So within 3 hours and 45 minutes, there's 47 bacteria in the sample. Brief, but if you were asked to find A, and a lot of times you would be, that's the skill of finding A is it's valid. I feel like we should just say 47 bacteria, but it's like 47 bacteria and the next one is like 35% on the way. You know what I mean? Is there a 0.35 bacteria? That's what I want you to talk to your biology teachers about is there a 0.35 bacteria? Could you see in a microscope the 0.35 develop? Will you ask them, please, your biology teacher? Serious. Yeah. I was just talking to a biology teacher. I should have asked. All right. If anybody did their assignment on paper, it's due right now. Yes, it's a lung infection. I think it fills up the lungs with liquid.
Yeah, but you said water.
Bacteria. Oh. That's a drowning. That's a drowning case.
That's not drowning.
I mean, is drowning by mucus still drowning? I think it is. Sorry to be disgusting. Does anybody want to turn their assignment in with by paper right now? Okay, right here. Yep, right here, right now. Name, date, period. Oh, okay. If you were absent, sure. Yeah.
I didn't notice my cousins were gone.
I remember I coped with it, I took the right steps, and so I've moved on, but it wasn't without a full processing.
Man, I did it in the book.
Rip it out, name, date, period, put it in the corner. What? What is this song?
Because I did that on in the book.
Right here, not in the basket, right here in the corner.
It's whatever's top news today. Regal cinnamon or cinema Captain America.
He was doing his best. It was his first girlfriend. That would be so funny.
Comic book movie. Wait, what? Yo, I just want to let you know that canned food.
I reported it.
You reported it?
According to the trending searches, canned food.
Oh, he was
Where?
Oh, I already heard of this yesterday.
Isn't it because they're sick or something?
It's botulism. That's what's in it.
Were you skipping, Gavin?
What else is trending?
For me?
Oh, and how'd it go? Did you think about, man, what's it like to be an orthodontist? Oh.
Yo,
Those orthodontists are making some pretty good money. If you're into money.
If you're into money.
The orthodontist option is a good route. Yeah, but how much money would it take for you to touch someone's teeth? Because you might just make that much money. Think about it. No, the medical professionals pay off their student loans pretty quick.
Yeah, but how do they end things at the same time?
They have a lot of depth. They make
Because Trump's gonna end daylight saving time.
And they're like really well disciplined also. Like just by character, really well disciplined. Gosh, I'm supposed to be going over yesterday's questions and I'm talking about the orthodontist. So, all right, here's 35. It was comparing this equation to this graph, okay? So the initial amount in this equation is 10, and this is tritium. And the initial amount in this graph, which is sodium, was 15, the y-intercept. So which sample has a greater initial amount? The sodium has a greater initial amount because it's 15. However, which sample has the greater amount remaining after 5 years? Plug 5 in here and you're at 7.5. Look at the graph at year 5 and you're only at 5. So yes, tritium has more remaining after 5 years. So the decay rate of sodium must be quicker. So even though they're both decaying continuously, they're not doing so at the same rate. The sodium rate was more quickly decaying than the tritium rate. And so we did some research about tritium last class, and
What is it?
it's a byproduct of a nuclear reactor, but I also think it's found naturally. You can look, but it's in glow in the dark stuff. It's in like glow sticks. They used to make like glow in the dark exit signs, and I think it's featured in Simpsons when Homer Simpson like is at work and the intro song and that glow in the dark thing like falls in the back of his shirt. I think that's tritium. And then they show the lake next to the nuclear power plant and the three-eyed fish from the nuclear byproduct. Anybody? Anybody seen that? Yeah. I mean, I've seen it. I mean, The Simpsons came out when I was a kid, so I'm going way back on that. I'm going way back. It might be different now than it used to be.
like some people believe that like this like just like predicts the future. That's like, you ever heard of that?
Oh yeah, I've seen it. The science fiction writers and comedic writers, I mean, they're not unintellectual. You know, I mean, there's a lot going on in there. All right, let's move on. We're gonna go ahead into 6.3. Head to page 564. There's a new word here, logarithm. So logarithms, the main thing you want to know, and if you want to write this down right on this page, logarithms solve for exponent. So we did a guess and check. When was it? We guessed and checked with the value of that car that was 25,000, and we tried to figure out when was it only worth 6,000, and it was between 6 and 7 years. Well, we're like very close to having that exactly figured out by using a logarithm. So you know that 2 squared is 4 and 2 to the third is 8, but what exponent on 2 would give you 6? 2 to what power is 6? Yeah, maybe it's 2.5. I think it might be, so that's a really good guess. But when it comes to decimal exponents, we don't really know them. The process less than 100 years ago there was published books of the exponents that people would go back and use. Someone did it by hand, but then we would just turn pages in books and find 2 to the 2.1, 2 to the 2.2, 2 to the 2.3, and we would use whatever number led us to 6. But now our calculators do it, and this thing called a logarithm is going to help us get to the answer. So this is the general idea. Logarithms solve for exponents. So your main objective today is to see a log problem and understand the equivalent exponential equation. So if b to the x equals y, that's the same as saying log base b of y equals x. It looks like yeah. You know what? I think it's best to look at the numbers that you know. Okay? We know 3 squared is 9. So another way to write that, since logarithms solve for exponents, is to say, okay, log base 3 of 9 is 2. See how the 2 is an exponent? The exponent that's here is the answer here. Logarithms solve for exponents. So the exponent is the answer. The exponent is the answer. The base is a subscript. And then the big number goes there. It's not always a big number, but it's called an argument. You see it. Let's look at some examples that are helpful. Right on page 564, if you want to fold that page over, I've highlighted the list of ones that you should recognize in exponential form. And right next to them, they'll show log form to help you. So looking at this, 2 to the 4th is 16. We know that's true. So if 4 is an exponent, that should be the answer of the equivalent log form, right? Logarithms solve for exponent, so there's the exponent. The base of the exponent is the subscript here on log. And the result of 2 to the 4th goes right next to the logarithm. The way we read this is log base 2 of 16 equals 4. And if you know this fact, you also know this fact. You just have to learn a new way of writing it so that the exponent's the answer. So 4 to the 0 power is 1. So 0 is the exponent, so that's the answer of the log form. Log base 4 of 1 equals 0. 12 to the 1st is 12. So we got the result of 1, and that's log base 12 of 12. The vast majority of your assignment today is just rewriting, just learning the equivalent forms. You'll be given this and asked to write it this way. And you'll be given this and asked to write it this way. Someone else is already waiting, I think. But I could be wrong. Is anybody waiting? Just feels like all day. The majority of things I talk about is the bathroom. Okay. So when the fractions and the negatives come in, just heads up, they're going to require more thought. They're a little less natural to figure out. Is 1/4 to the negative 1/4? Yes, because negative exponents lead to reciprocals. So this is log base 1/4 of 4 is negative 1. All right, here's some steps for you. And then we'll try the gray box problems. And then it will click. It will click in just a few more minutes. So if you're asked to rewrite an exponential equation as a logarithm, step 1, you actually write out the word log, L-O-G. In Big Ideas Math, you're actually going to use the keyboard and key in L-O-G. You write the base of the exponent as the subscript. So this big 5 goes mini down low, subscript. It's mini and it's dropped down. The argument, 25, we call it an argument here, but I call it the results, goes in next. And just remember, the exponent should be the answer of the logarithm. So when you get lost, you have to think logarithms equal exponents. The exponent should be the answer. So you just have to figure out where the other two numbers go. When you're ready, do the gray box questions on 564. And I'll put the answers, you can see if you got it down. Ready to try the gray box questions? Okay, so just get into a new little habit of rewriting. So the 3 will be the base. So the little guy here becomes a big 3. The result of a log equation is an exponent, so that'll be 3 to the 4th equals 81. And that is true. I can check that in the calculator. 3 to the 4th is 81. This one reads 7 to the 1st is 7. And then 14, 0 is the result, so 0 will be the exponent. 14 to the 0 power is 1. And then it's right here, you don't really want to rush through this. Like, you don't want to just, the more you really look at this and talk about it and understand it, rather than just, copy the format, we're going to look at 1/2 as a base. That's kind of a tricky base to begin with, fractions. negative 5 as an exponent, and that's going to equal out to 32. I don't really buy into that as much as I bought into 7 to the first is 7. So I have some tips up here when things get more challenging. Negative exponents will turn a fraction into a whole number. So when I think about 1/5 to the negative 5, negative exponents make reciprocals. So this is actually 2 to the 5th power, which is 32. So fractions turn into whole numbers with negative exponents. That's going to be helpful when things get more difficult. All right, so now we'll practice writing out the word log. So writing a logarithm, so first I write log log. The base is a subscript, so sub 7. I like to write in the answer right away because I know logarithms are exponents, so the 2 is definitely on the answer side. And the last number I fill in is that 49. And that reads log base 7 of 49 is 2. Log base 50. I know that the exponent's the answer, so I'm going to throw the 0 out to the right there. And I got a 1 in the argument column. You're welcome. And this is true. 4 to the negative 1 is 1/2. I mean 1/4, because that negative will make that fraction. So I write the word log. The base becomes a subscript. And logarithms solve for exponent, so the exponent goes as the result. Ooh, 256 is a pretty high number. 2 to the 8th, 256. I might check that if I was on my own here. It is. Log base 256. It's going to equal 1/8. Log base 256 of 2 is 1/8. Jacob?
So basically, the answer to this is just whatever the subscript is the power.
Yes. Well said. All right, let's skip to the next gray box problems and then I'll be done. I got like 4 more I'll do and then I'll be done. All right, last section, evaluate. If necessary, use technology. I'll tell you a calculator button here in just 1 second. So for all of these, they're missing the equal sign. They're not telling you what the exponent is. So you have to figure out the exponent. We're figuring out what the answer is in logarithm solve for exponents. So I have to think. Got to do some thinking. 2 to what power is 32? I'm thinking about what exponent of this base would give me that result. And 2 to the 5th is 32, so that answer is 5. And now I have to think 27 to what power is 3? How does an exponent make a number smaller?
A third,
Fraction.
yeah.
Fraction.
Sorry.
If an argument is less than a base, if a number actually has to get smaller, you need to consider fraction exponents. So back when we were doing fraction exponents are roots. So 27 to the 1/3 is really the third root of 27. So we need a fraction exponent here. Number 11. When there is an invisible base. What?
Is it 0 or 1?
It's a tenor.
What?
It's 10. It's an invisible 10 there. So for a really long time, the only logarithms anyone thought they were ever going to do was base 10. They were using it for like scientific notation, like really big long distances. They were actually using it to sail ships. So they didn't write the 10 in because it was their only idea was base 10. So anyway, if it's invisible, it's base 10. That's called the common log, base 10. So 10 to what power is 12? Yeah, this is where I'm going to tell you a button on a calculator. So log, the log button is here underneath the second button. You have to hit it twice to get log, 1, 2. And so that's log base 10. So hit it twice. It'll say log. And then we'll put in 12 and then hit enter. And there it is. And it says round to 3 places. So we're going to go 1.079. And it used to be before calculators that people who did math, they just had a huge book, like an encyclopedia of all the powers. And they would just flip in there. All right. A lot of people misread this as IN. This is not IN. This is actually LN. And it stands for natural log. That's the log of spirals. That's log base E. Euler's E. So ln is called the natural log. And that's this button hit once. It's actually the very first. It's right underneath the second button. It's like our very first button, ln. So ln 0.75. 0.75 is less than E, 2.71. So this has got to be a negative exponent. And it is. I'm thinking E to what power? This must be continuous decay. Negative 0.288. Gosh, that took a long time. I'm with you guys. All right, I'm going to open up your assignment online right now. It's 1 through 21. Now, the problem